Hello, today we're going to be talking about rationalizing the denominator for rational exponents. I'll explain more what that means in a second, but first let's kind of pause and talk about when we're done simplifying things that have rational or fraction exponents. So in order for an expression to be considered completely simplified, all three of these things has to be true. This first one, no negative exponents, is just like when we talked about exponent rules earlier in the year. We don't write negative exponents in final answers. This one right here, any exponents in the denominator are positive integers, are what we're going to focus on today. And I'll show you what I mean by that more in a second. All fractions are reduced. We've already kind of covered that. If we have coefficients that can be reduced, we do so. And we write our final answer fraction exponents as fractions, not as decimals, not as mixed numbers. And we do want those fractions to be reduced. So these are the three things to kind of keep in mind when you're deciding if you're actually done with a problem. So here's, oops, that's not what I want to look for, just kidding. Here's things I'm talking about today. So if you look at this example right here, I have 1 over x to the 1/2. Our second rule said we could not have any exponents in the denominator that are not positive integers. Positive integers are like numbers like 1, 2, 3, etc. We don't want to see fraction exponents in the denominator. And that's what we have going on right here. So the way we undo or get rid of a fraction in the denominator is we're going to use our product rule. We want to take whatever number is in the fraction here and get it up to the nearest whole number. So what we're thinking is, what number do I need to add to 1/2 in order to get it to a whole number? Well, 1/2 is closest to the whole number 1. What do I have to add to 1/2 to get to 1? I add another 1/2. In order to add an exponent, I need to be multiplying by something with the same base. So in order to get this x to the 1/2 to turn into an x to the 1, I need to multiply this by x to the 1/2, because x to the 1/2 times x to the 1/2 gives me x to the 1/2 plus 1/2, which is x to the 1. But anything I do to one part of the fraction, multiplying-wise, I have to do to the other. Once I actually carry out this multiplication, my problem will be completely simplified. Up top, 1 times x to the 1/2 is just x to the 1/2. Down in the denominator, we've already done the hard work for this. 1/2 plus 1/2 is 1, so x to the 1/2 times x to the 1/2 is x to the 1, which is the same as x to the 1/2 over x. So to get from here to here, we are thinking, what do I need to add to this fraction right here to turn it into a whole number? Multiply top and bottom by x to whatever that exponent is. Let's try another one. So this time, my fraction exponent in the denominator is 5 over 3. And so we want to get that to a whole number. 3 over 3 is 1. We always want to go up. The next whole number would be 6 over 3, which is 2. So what do I need to add to 5 over 3 to turn into 6 over 3, which is the same as 2? 5 over 3 plus 1 over 3 gives me 6 over 3, which is 2. So this time I'm going to multiply top and bottom times y to this fraction, 1 over 3. Putting that all together, 1 times y to the 1/3 is y to the 1/3. Down in our denominator, we've already done the work for this. 5/3 plus 1/3 is 2, so I get y squared. I'm going to do some more examples today that might have a little bit more complicated things going on. Generally speaking, you're trying to get to a 1, 2, or 3 exponent in the denominator. I'm not going to make you try to do something like where you end up with like y to the 20 in the denominator, or a very large number like that. So that's the idea. We don't want to see fractions in the denominator in our exponents. So here's our rules again. More examples. These ones are just a little more complicated than we just looked at. We want to see only positive exponents in our answers, and we don't want to see any fraction exponents in the denominator. That right there is the part we're really focusing on. No fractions in the denominator for exponents. So let's take a look at number 1. Nothing's going to happen with this m right here because it's the only m in the whole problem. Nothing's going to happen with this coefficient 3 right here because it's the only coefficient in the whole problem. The thing we need to focus on right here is this n to the 4 over 3. What do I add to 4 over 3 to get it to a whole number? So 3 over 3 is 1. 6 over 3 is 2. So 4 over 3 is going to be, if we're going up, only going to be closest to 6 over 3, which is 2. What do I add to 4 over 3 to turn it into 6 over 3? I add 2 over 3. So that means I'm going to take the top and bottom of my fraction and multiply it by n to the 2 over 3. Let's put that all together. Up top, we're just kind of collecting those things. They're not like exponents, so we can't combine them or anything. M to the 1/2, n to the 2/3. In your denominator, like I said, nothing changes about that 3. And then we've done the hard work for this part. 4/3 plus 2/3 is 6/3, which is 2, so we end up with n squared. Looking at our final answer, I see only positive exponents. I don't see a fraction exponent in the denominator. We are good to go. Up to this point, we'd only wanted to see like one of each variable, but in order to do that rationalizing process, in your final answer, sometimes you're going to see two of the same variable like you did here. If you were to try to simplify this any further, you'd end up with a negative exponent, which would just make you start this whole process again. So this right here in the strange little box there is your final answer. Let's try another one. So 3 over 2 doesn't reduce. U to the 3/2 is going to stay the same because it's the only u exponent. The thing we need to focus in on is this v. So what do I add to 3 over 2 to turn it into a whole number? So if I'm thinking things with denominator 2, 2 divided by 2 is 1. 4 divided by 2 is 2. So 3 over 2 is, if we're going up, closest to 4 over 2, which is 2. What do I need to add to 3 over 2 to turn it into 4 over 2? I need to add 1 over 2, because 3 over 2 plus 1 over 2 gives me 4 over 2. So I'm going to multiply top and bottom of my fraction by v to the 1 over 2, or v to the 1/2, whatever makes sense for your brain. Let's write our final answer. Up top, just kind of collect everything together. 3u to the 3/2, v to the 1/2. Denominator 2 stays the same. We know that when we combine these together, we get v squared. That was the whole point of doing this process. This right here is your final answer. Some of these, like 3 and 4, you're going to try to, if you can simplify anything first, go for it. So let's see, do we have 2 of anything that we can try to simplify here? Coefficient 3 is going to stay the same. For now, this is the only x, it's going to stay the same. But for my y's, I can use my quotient rule, top exponent minus bottom exponent. 5 over 3 minus 3 over 2. What does that give us? Let's use Desmos to help us out. Let's change that into a fraction by clicking this fraction guy here. We get 1 over 6. Since it's a positive 1 over 6, it goes in the top of our fraction. Okay, so we took care of the y, so we don't have to worry about rationalizing the denominator for y. We do, however, have to worry about it for x. So looking at this right here, what can I add to 5 over 4 to turn that into a whole number? So 4 over 4 is 1. 8 divided by 4 is 2. So if we're going up from 5, 8 over 4 is the closest one. What do I have to add to 5 over 4 to turn it into 8 over 4? 5 plus 3 is 8, so I need to add 3 over 4. So I'm going to multiply top and bottom by x to the 3 over 4. And then let's just clean up our final answer. Up top, 3y to the 1 over 6, x to the 3 over 4. Denominator, we know that when we do this, we get 2, so that becomes x squared. As before, like if you're writing your final answer here, if you did x to the 3 over 4 first, then y to the 1 over 6, that would be perfectly fine. So order of the variables is not super important. One last one. What can we simplify first? So nothing is going to change about that coefficient 4. Since this is the only u in the whole problem, it's going to stay the same for now. It won't stay that way forever. V's, though, I have the same exact thing in the top and the bottom. And if you thought about your quotient rule, if I do 5 over 3 minus 5 over 3, I get 0. That means your v's completely cancel. So you can think of that one or two ways. You can think 5 over 3 minus 5 over 3 is 0, they cancel. Or you can think I'm dividing something by itself, it cancels. So regardless, those are gone. When you have the whole top or bottom of a part fraction cancel, it's a 1. So we do need that placeholder 1 up top. So now the only thing we have to worry about is this u to the 3 over 2. What do I add to 3 over 2 to turn it into a whole number? So 2 over 2 is 1. 4 over 2 is 2. So to get from 3 over 2 to 4 over 2, what do I add? 3 plus 1 is 4, so I add 1 over 2 to make that happen. That means I'm multiplying top and bottom of the fraction by u to the 1/2. Now we clean it up and write our final answer. 1 times u to the 1/2 is just u to the 1/2. Let me make that half look a little bit prettier. And then down in your denominator, 4 stays the same. 3/2 plus 1/2 is 2. So this part right here turns into u squared. So I won't get anything too crazy complicated. In your notes, I have a cheat sheet for instance, if you're not super great at coming up with these off the top of your head, I do have a cheat sheet for different denominators and the different whole numbers you can get from those. So feel free to use your notes to help you out with that. Like I said, I won't have you go into crazy big whole numbers down here, mostly 1s, 2s, and 3s. That is it for today. I hope you have a wonderful day.